Question 15 shows that there is an eyepiece reticule and also the stage micrometer. And also the questions shows that it is using the eyepiece reticule to measure the size of the specimen. So based on this, we can say that this question is also a question type that is measuring the cell using the eyepiece reticule. So we can just follow the 3 steps in order to solve this type of questions. So the first step is always finding one pitch on the stage micrometer. So this should be the step number 1. Find the one pitch on the stage micrometer. So based on the questions, we can see here, a student calibrated eyepiece reticule using stage micrometer, and each pitch of the stage micrometer was 0.01 mm. So meaning that the question has actually tell us one pitch on the stage micrometer is equals to 0.01 mm. So that means that for this step, well, you don't really have to calculate. But because the unit given is mm, so we will just convert this millimeter to become the micrometer in this step number 1. Yeah, so based on the questions, they have tell us that one pitch on the stage micrometer is equals to 0.01 mm. So we convert it. So 1 mm, you want to convert to micrometer, you have to times 1000. So it will be 123. So it will be 10 micrometer. So meaning that we will do the conversion here. So one pitch on the stage micrometer is 10 micrometer. It's 10 micrometer. We just convert. So that's all for the step number 1. Then next we can proceed to step number 2, finding one pitch on the eyepiece reticule. So this would be step number 2. Find one pitch on the eyepiece reticule. So to find that, you have to know how many pitch of the eyepiece reticule match with how many pitch on the stage micrometer. So again, in the questions, we can see that under times 10 magnification objective lens, so meaning that this is under 100 times of magnification, yeah, under 100 times magnification, 10 eyepiece reticule unit will match with 8 pitch on the stage micrometer. Yeah, so that means that 10 pitch on the eyepiece reticule is equals to 8 pitch on the stage micrometer. So based on what we get just now, one pitch on the stage micrometer is 10 micron. So we will sub into here. So that means that 10 pitch on the eyepiece reticule is equals to 8 times 10 micrometer. So with that, that also means that one pitch on the eyepiece reticule is equals to 80 micrometer divided by 10. Yeah, divided by 10. So that means that one pitch of the eyepiece reticule is equals to 8 micrometer. Yeah, so once we have the one pitch on the eyepiece reticule, then we can proceed to step number 3, which is to measure, to measure the cell or measure the specimen. But there's one problem here, because if you read the second part of the question, which is here, you will see that these 8 micrometer for one pitch on the eyepiece reticule is actually the size when it is under 100 times magnification. Yeah, so I will write in green color. This one is actually the actual size. Yeah, it's actually the actual size of this one pitch of the eyepiece reticule of 1 PE, yeah, under 100 times magnification. It's actually under 100 times magnification. Right? And when the questions use the eyepiece reticule to measure, Okay, when the questions use the eyepiece reticule to measure, they have changed the objective lens. The objective lens now is changed to 40x objective lens. Yeah, the same microscope was used, but objective lens is 40 times objective lens. So meaning that it is now under 400 times magnification. It is under 400 times magnification, right? So that will also means that the size of one pitch on the eyepiece reticule will change when you change the magnification. So because of this, well, we need to find, for this step number 2, we need to further find one pitch of eyepiece reticule at 400 times magnification. So that is what we need to further. So next is, this one is at the 100 times magnification. So we need to further find, it is still under step 2, it says that we need to find one pitch on the eyepiece reticule under 400 times magnification. So this is what we need to further find, because when you find one pitch of eyepiece reticule size under 400 times magnification, then only then you can use this to measure, to measure the size or diameter of this alveolus, because this alveolus is obviously, the alveolus is observed under 400 times magnification, and they're telling you it is 96 eyepiece reticule unit. So because of this, yes, we have to further find that under different magnification. So how to do this? Well, before we proceed, we need to understand a concept on this eyepiece reticule. So this concept is linking the magnification and also the image size and also the actual size of this eyepiece reticule pitch. Yeah. Okay. So now let's say we have a microscope. Okay, so for eyepiece reticule, their size is always the same. Yeah, it is always the same size regardless of the magnification. So meaning that the image size of this eyepiece reticule is always the same, no matter what type of the magnification. So let's say the red color one is the eyepiece reticule. Let's say we have a few lines here. Or maybe I make it larger. So let's say this is the eyepiece reticule, and under 40x, let's say, under 40x magnification, the size of the size of this one pitch on the eyepiece reticule, 1 PE, maybe it is, I make it, let's say, 10 micrometer, let's say. Right, let's say it's 10 micrometer. So meaning that, let's say we observe a cell, we observe a cell under this 40 times magnification. So let's say the cell size is just 10 micrometer. So what you will see is that the size of the cell will be just one pitch. And let's say the size of the cell is 10 micrometer. So we will see that when we measure that, it is equals to one pitch. One pitch of this eyepiece reticule. But when we actually magnify further, if let's say we magnify further, so I will copy this whole thing. So now let's say we have magnified further. When we magnify further, let's say now it is under 400 times magnification. Under the 400 times magnification, the eyepiece reticule is still the same size. It won't change. That's why we say the image size of this eyepiece reticule is still the same. Right? Only stage micrometer and only the specimen they will change in the size. They will enlarge when we enlarge or when we increase the magnification. But for IP square TQ, the scale is always the same. All the IP square TQ pitch, the size is always the same, no matter you increase from 40 times to 100 times to 400 times or even to 1000 times magnification, the size of all of this pitch on the IP square TQ is always the same. Only the size of the stage micrometer and also the size of the cell will be enlarged when we increase the magnification. So that is the major difference. Yeah, so that's why the image size of these IP square TQ is always the same, no matter what magnification you increase. Okay, but the actual size of these one pitch on the IP square TQ will be smaller when you increase the magnification. The image size will remain the same. What we see under the microscope will still be the same size, but the actual size of this pitch will be smaller. Why? Because now we look at the cell. The same cell that is 10 micron, under 40 times magnification, it only cover one pitch. Because that is the size, 10 micron, and the size of one pitch is 10 micron. So that's why you can see the cell is only one pitch. But under 400 times magnification, you can see that the size of the cell will be increasing. It will be increasing a lot. So now we can see that the cell will be so huge. Is that means that the cell is increasing in the size? Actually, no, it's just the image. Yeah, the cell is still, the size of the cell is still 10 micron. It's just that because of the higher magnification, so that's why the image size of the cell also enlarged. But this whole cell is still 10 micron. So meaning that each of these pitch, yeah, every single pitch on the IP square TQ here is actually having smaller micrometer. Because let's say the whole cell here is 10 micrometer. So that means that this one pitch on the IP square TQ is only 1, 2, 3, 4, 5, 6, 7, right? So it's actually only maybe 2 or maybe 1 micrometer only. So that's why we said, even though the image size is the same, but then the actual size on the pitch of this IP square TQ has decreased. Yeah, it has decreased, right? So obviously, yes, we can see it based on the size of the cell when we increase the magnification. So based on this concept, what is important to know is that when the magnification increase or decrease, the image size of the IP square TQ is always the same. The only difference is their actual size will be different. So based on this concept, we can apply it here in order to find one pitch on the IP square TQ, yeah, under the 400 times magnification. So what we know here is magnification formula is always magnification equals to the image over the actual. And then we know that image size of the IP square TQ is always the same. So that's why we can rearrange it so that it becomes image equals to magnification times the actual size. Okay, so based on this, now we apply the concept just now. The image size of the IP square TQ is always the same regardless the magnification. The only thing that it changed is just the actual size. So based on this, we can state that, okay, based on this, we can say that the image size of this IP square TQ, yeah, under 100 times magnification, because at the beginning for this one, what we count is 100 times magnification because it's using 10x IP, 10x objective lens, yeah, so it is 100 times magnification here. So that is the actual size. So based on this, we can say the image size image size of the IP2 under 100 times magnification is equals to the image size of the IP2 under 400 times magnification. It is the same. Okay, so based on this, next we will fill in. Yeah, we will replace the image size with the magnification times the actual size. So that will mean that the magnification, which is 100 times magnification, times the actual size, which is the 8 micrometer, will be equals to the magnification, which is 400 times magnification, and actual size, which is the actual size of one pitch on the IP2 that we want to find. So we can just replace it in. So that's why magnification times the actual equals to magnification times the actual. So the magnification here would be 100 times. And when the magnification is 100 times magnification, the actual size of one pitch of the IP2 is 8 micrometer. So that's why we will times 8 micrometer. So it will be equals to the magnification, the new magnification that we change. It will be using 40 times objective lens. So that's why it is 400 times magnification. So the new magnification will be 400. So the actual size of one pitch of the IP2 is what we want to find. So based on this equation, then we will just rearrange. Yeah, we'll rearrange it. So that means that 800 micrometer divided by 400, it will be equals to the actual size. So that also means that the actual size, the actual size, So based on this, the actual size of one pitch on the IP2 at 400 times magnification is actually equals to 800 divided by 400, that would be 2 micrometer. So based on this, we now know that this one pitch, this one pitch of the IP2 is equals to 2 micrometer. So this one is basically the actual size under 400 magnification. So with that, now we can use this to measure. Yeah, we can use this to measure and proceed to the step number 3. So now we proceed to step number 3. Step number 3 is when we measure the size. So to measure the size, we need to know how many pitch on the IP2 is that. Yeah. So it states that the diameter of the alveolus is found to be 96 IP2 unit. So that means that the diameter of the alveolus is actually 96 pitch. So diameter of the alveolus is equals to 96 pitch on the IP2. And this data is taken when it is observed under 40x objective lens, which means that under 400 times magnification. So that's why when you want to find out one pitch on the IP2 equals to how many micrometer, you have to use the one pitch data from 400 times magnification. You have to use this one and not this one. Okay, you have to use this one because it's under 400 times magnification. So 1 PE is equals to 2 micrometer here. So based on this, we can sub here. So that means that the diameter of the alveolus is 96 times 2 micrometer. And with that, we can say that the diameter is 192 micrometer. So that's basically how we find this answer. So for this question, yes, it is a bit challenging, but well, as long as you understand the concept, you can always apply the magnification formula into it in order to find the actual size of one pitch of the IP2 under different times of the magnification. So same thing if let's say it is change to 1000 times magnification, you can always do the same thing in order to find out one pitch on the eyepiece reticule is equals to how many micron under different magnification. So same thing again, before we end, we have to remember here the image size. The image size of the eyepiece reticule don't change. It don't change. Yeah, it will be always the same regardless of the magnification. What is changed is just the size of the cell will change, but that is the image size of the cell. The actual size of the cell is always the same regardless of the magnification. It's always the image size that change. Well, for the eyepiece reticule, it is the image size that don't change because image is what we see. So only what is changed for the eyepiece reticule is only the actual size. So the concept is almost similar like the FOV relationship with the magnification, the size of the FOV relationship with the magnification. So that will also means that whenever the questions is related to the diameter of the FOV or the size of one pitch on the eyepiece reticule, well, when it is related to magnification, both of these actually apply the same almost the same concept, and that will also means that you can use the same way to solve these to solve this type of question. So that will means that yes, whatever questions related to change of diameter of the FOV or change of the size of one pitch on the eyepiece reticule due to the changes of magnification, we can always use this way.